cover. And it's this concept of momentum. And momentum is basically how you could think about it as how difficult is it to stop an object that is moving. So if a boulder is rolling down a hill at you, okay, and you're going to have to try and stop it, you have nowhere to go.
Or you're Indiana Jones.
Yeah, like Indiana Jones, you can't run away from it, you need to stop it somehow. So obviously, would you rather have a more massive boulder or a less massive boulder?
More mass.
Less mass. And how about speed? Slower speed. Okay? Because those are the two factors that affect what we call momentum. It's mass and speed. Okay? So the formula to calculate the momentum of an object is the mass of the object times the velocity of that object. So if you have a 50 kilogram barrel rolling down that a gorilla is throwing down, you have to jump over.
Jump over it.
Yeah. And because you have to get
500 kilograms per mile per second.
So when we calculate the momentum of this barrel that's rolling down at you, the momentum, we again write the formula. Substitute our units, and we get an answer of 500. And again, we combine our units, kilograms, meters per second.
Mom equals 500.
Okay.
Wait.
You're a busy man.
Also, which would hurt more? Okay, a 200 kilogram linebacker
What's that?
running at you at 2 meters per second, or a 100 kilogram safety running at you and hitting you running at 4 meters per second.
They're equal.
Right, they would be the same. They would have the same momentum,
Yeah, but the linebacker's fatter.
but they're running slower. So again, momentum is a factor of both the velocity as well as the mass.
Think about it, it's like spectrum.
So let me ask you this, could a marble, tiny little marble, and a bowling ball, could they have the same momentum?
Yeah.
Yeah.
Well, what would have to be true, Lori?
The marble would have to go really fast and the volleyball have to be really slow.
Yes. If the marble rolling very quickly and the bowling ball were rolling slowly, then they may have the same momentum. Another area that this comes into play is that sometimes people want to drive a larger car because they feel like it's more safe. Now, is that true?
No. In some cases, yes.
Yeah, in lots of cases it is. And it has to do somewhat with momentum. Because a larger sort of big truck has greater what? Mass, and is going to be more resistant if there's a collision with another object. Because the higher mass is going to give it a greater momentum, so it can withstand maybe some more of that force. Now we talked about yesterday's centripetal force. Okay, the force that keeps an object moving in a circular
You have a yo-yo?
pattern.
Would I swing
All right, and we said that the force that keeps the object moving in a circular pattern is called centripetal force. And if the string were to break,
Go flying.
it would continue forward in a straight path.
And then hit me in the teeth and knock him out.
And then you would swing
Yes, and I would be very happy.
So,
Whoa, 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 whoa.
Come
whoa,
on, dude.
whoa. Easy there.
What is this thing you call the path of whatever?
What?
Inertia.
Alright, so
You try that thing again where it's like the
You
water.
were
and
gonna
then go,
answer
like,
my
really close to
question?
it.
no, I've done it before. Alright, I do it to one time only. So
What if there was just
if you, this comes into play if you're in a car and your mother takes a turn too fast.
Or you might fall over, flip.
What happens to you?
You go like that.
You go to the outside, or if you're in one of those scrambler rides at the carnival, right? Where do you not want to sit?
Inside.
On the outside.
Outside.
Because that's where
Because as this ride is rotating, okay, your body wants to continue in a straight path because of inertia. But as the ride curves, okay, you get pushed against the outside of the cart. And anybody that's in the cart is also being pushed to the outside, smushing you on the inside. Okay? So whenever you take a turn, your body wants to continue straight, but since the car is turning, you get pushed into the side of the car. The same is true with the bucket of water. That's why I can swing it. Because the water,
fill it all the way?
if I put water in, the water as I swing it wants to continue forward. But what's preventing it is the bucket. And so the water stays pressed against the outside of the bucket and will actually stay in the bucket because of that force of inertia.
Fill it to the top. Like, very rim, then do it.
No.
Why not?
One more time, that's it.
You not trust the laws of motion?
I do, but there's some margin of error here. There's a lot of
Come
water.
on, fill it more. More? No. No, come on, you need more than that.
You need more.
Alright.
Oh wait, no, that's the law. That's the law.
Water!
I need
Water!
Go slowly.
Slow.
Not very slow.
Yeah.
Benjamin, tip it. Tip Benjamin.
Oh! Yay! Come on! Oh.
So if you keep it
Spill!
going,
Spill!
Let go.
if I let go,
Yeah, let
that would
go.
be bad.
Do it!
We don't need to
I want to do my
Mr.
favorite.
Dude, waste that clean water.
Alright.
This is trust. If you're not favorite teacher, you just spill that on your pants.
Oh, great.
Please.
I'm okay with not being your favorite teacher.
What does inertia mean?
Alright, so you don't have this slide, but anyway, when you make a quick turn, you get pushed against the side of the car because of inertia, because your body wants to continue a straight line, but the car is moving.